Good afternoon. Good afternoon, everyone, and welcome to this week's webinar on driving distributed generation. My name is Maloba Tshehla. I am here in my capacity as the spokesperson of the South African Photovoltaic Industry Association. So it is my pleasure to welcome you all to today's session. I've got a very awesome line of speakers, highly experienced, and very ready to give us some really good insights into the fundamentals of building distributed generation projects. I think very quickly, to start with the housework, of course, just to thank our sponsors for the series in general, that being RMB and Genesis Eco Energy Developments. Thank you very much for sponsoring the entire series. And to this specific webinar, just a big thank you to Trina Sola Lawrence, who's also on our panel and will wrap up for us today. It's because of your kind donations and support for this work that we're able to do this in really making renewable energy and solar PV accessible to everybody under the South African sun, so to speak. So without further delay, I just want to get into my panel, and how we've structured today is really to walk all our participants through the various scales of distributed generation. So we're going to be looking at your residential scale solar PV installations and the fundamentals of that. We will then move on to commercial rooftop installations, and then we will look at ground-mounted solar PV installations, just to give our viewers a sense of the fundamentals as you scale up these various installations and what it really takes to make your project come alive. Luckily, I don't have to do that. I've got this amazing panel of speakers, and so I'll just jump straight into it with our first speaker, and that'll be Greg Walton, who's a director at, I'm assuming it's pronounced MySolar. Greg has been installing and designing PV systems for well over a decade across the various scales, and he's in charge of PV system design and implementation. So Greg, over to you to bring us into this discussion looking at the residential scale PV systems and the fundamentals thereof.
Thank you, Manoba. Hi, everyone. I will start with just really talking about the various, the simple residential installations. We've done quite a lot of them. And although it's not absolutely critical to get a residential site perfect compared to a commercial, it really is important to try your hardest to make sure that what you're doing is offering a very good product. So what I'm going to do is just go through some of the key facts to keep in mind. I mean, we have a company, we have a way that we do things, and obviously there's many ways to skin a cat. So I'm going to give you our version. It works for us. There's some parts which I don't think should be changed, but there's other parts which you guys are doing in your own way, which hopefully that works as well. So I'm not saying this is the only way to do it, but it is something that we've had success with. There's just four things that I really have to stress. We think about very carefully when we're doing a system, residential system. Often a client relationship is completely critical. We have many situations where if we have a problem on a system, or if we have a problem at a installation, a good client relationship helps us ease things through, and we resolve issues quite easily. Also, a client relationship is very important when it comes to your design. Let them understand what's going on. Okay, so after your assessment, remember, you the professional, you the one who's going to be doing a system design, you the one who's going to recommend what they install. And when it is installed, it's your responsibility. If something goes wrong there, or it doesn't work according to the way you said it would work, they're going to come back to you. So just make sure that what you're thinking about and what you're offering is something that works properly. Next, we've got, it's quite funny. I mean, down to literally the last screw that goes in the wall somewhere, or the last little bit of trunking or bosal or whatever it is that you're putting on a wall or somewhere. everything you do is an advert for your company. If you want your brand to grow, if you want your business to, move forward, then you've got to make sure that you do something which somebody's happy with. And again, your client relationship is critical. Yeah, they look at what your team's done, and they will recommend it if it's a great job. So everything, it's an advert for your company. Yeah, and then, of course, if something goes wrong, you're responsible. So make sure you do it right first time, well, at least first time or even second time. Make sure that everything works nicely. You don't have to keep coming back to site and fixing this and fixing that, because when you do that, you're responsible for that, and you're the one who's going to end up paying for it. So very important. Try and keep those 4 things in mind, and you should end up with a nice product. Okay, so when it comes to doing these installations, the designing planning stage, obviously there's certain steps that we go through. Client understanding, again, back to client relationship. So the client needs to understand what it is that you're offering them. You need to understand what the client wants. So if we keep going there, Kim, you need to understand what the client is expecting and what he wants. So he might have been told something by one of his friends. This is what we're going to go off grid, Greg. We want to do this. We want to do that. You need to know what it is that he's expecting, so you can keep that in mind when you go ahead with your assessments and with your designing. Of course, budget's an issue. Some people don't have a budget. That's quite nice, but most people have a budget. You need to try and work within that budget, and obviously you've got to try and get them the best possible product for their budget. Then when you're doing a site assessment, there's a lot of things that you might need to do, and you want them to understand the steps. Part of your client relationship building is letting them understand that you're a professional, that they're leaving this in your hands. You're going to be offering them something which you believe is the right thing, and go through the steps with them. Let them know why you're climbing on the roof, and let them know why you're looking at their DB board, and let them understand all the bits and pieces which you need in order to do a good assessment. Metering is important. I mean, sometimes on a residential, it doesn't seem like a meter is an important item to put in and try and do some monitoring on, but it will help you a lot. Obviously, if you've got a site where you've got a tiny little roof, and no matter what you do, you can put 5 kilowatts on the roof and you might need 10, metering is not going to be that important. But on a large site, we have houses where people are consuming 150 kilowatts a day, and it helps to understand where that consumption is, when it is, of course, because your time of use is highly important. And then you can make sure that you're designing something that is going to work for them. Of course, you've got phase balancing, power factor correction, which might be an issue as well in some of the larger homes, and you might be able to assist with that. And of course, that's what metering will help you with as well. Right. Yeah, electricity bills. I mean, that's an obvious one. If you can get as many bills as you can, and some people are prepaid, so you might find out if they've got a record of all the prepaid slips that they've got. You can start to look at that. That's part of your design criteria. Thanks, Kim. Right, the site assessment. So we've all been there. You arrive there, you open the DB board, you have a look, and you just kind of fall back very quickly. The DB board's condition is, very important. You look at it, it might be something that you can work with very easily. It might have a lot of space. You might be able to tap in, no problem. Or it might be a complete disaster. We've had DB boards, which, I'm sure you all have. We've had wooden DB boards. You just can't believe what's out there. So you need to make sure that you check the condition of the DB board. A lot of sites have many sub-DBs. You might have pool pumps or outhouses or outbuildings or flats or whatever it is. And you need to understand the reticulation and how the internal system works so that you can plan accordingly. Some people want to have load shedding protection in their flat, and it might not be possible, but you need to be able to explain why. Obviously, everything is possible at a cost. Main breaker size, of course. And request the latest COC. It's surprising how many people don't have a COC. I mean, obviously, if they've been in their house for many years, they wouldn't have one. But some people have just bought a home, or they have an electrician who's done some work and issued them with a COC. See if you can get that. It's very helpful. Roof. Well, of course, on the roof, you've got to have a good look. Visually inspect it. Obviously, you need to see what type of sheeting you'll be working with, whether it's corrugated iron or chromadeck or tiles. You might have slate, you might have asbestos, which is a tricky one. So all of this is going to help you with an assessment. Funnily enough, we see competitors of ours doing assessments purely with kind of Google Maps. I mean, you know, it's kind of irresponsible because you're never going to get it right. You can't always see what a roof sheeting is from Google Maps. It's very difficult. So rather get on site, go and have a proper look yourself. And of course, the condition of the roof. The last thing you want to be doing is placing panels over a leak. If there are any leaks, ask them about them. If they know about them, it's very helpful. You need to have that repaired, or they need to have it repaired before you put your arrays up. Otherwise, it's very difficult. You might look at a tin roof and it might have rust marks and holes all over it, then the sheeting needs to be replaced before you put panels up. Obviously, you know, for your design, you need to understand the angle, the pitch angles, azimuths, and of course the overall size. Bearing in mind you've got some distances from the edges of the roof and of course from the pitch, but all that is part of your assessment. Siting, yeah. So I mean, you've all been there. You arrive on site and there's a tiny little room underneath the stairs, which if you're really, really small, you might be able to crawl in there and they go, can you put it over there? No, we don't. We want to make sure that we've got a really good site for the inverters and batteries, and they need to be, you know, in close proximity to the DB board. You need to understand the cable run, so you can, for your costings, you need to, of course, know that. For your PV, how easy is it to get the PV down to the system? You know, how do you get from your system into the DB board? So you need all of that, obviously, for your calculations. Kim? Yeah, design and planning. So your system design. So then again, you go onto your design constraints. So what is the size of the array you can possibly fit on the building? Is that a design constraint? Well, of course it is. If you've got no limit to the size you can put up there, then that's not going to be an issue. You need to look at the other parts that are your constraints. But of course, in a lot of houses, you can only fit what you can fit on the roof. Otherwise, it doesn't, you know, you can't put panels on the south side or in places where there's terrible shading. So that's a design constraint. Budget, of course, we talked about earlier. Local regulations. So in most municipalities, you're going to have a list of inverters that they've approved. Obviously, you've got to stick to those. And they might even tell you what size you can use. Metering results will give you also a restraint. It'll be a design constraint. So your metering will tell you what you should or what you shouldn't do. So obviously, working within the constraints, we want to offer the best system to give the most effective return on investment. There's no point in, you know, putting on a massive system which just is not going to be used properly. It means that they're spending a lot of money. At the end of the month, they're going to look at how much money they've saved in, and they're going to say, oh my gosh, I put, you know, hundreds of thousands in there and I've saved 1,200 rand. And who's going to have the bad rap? Well, obviously, it's going to be your company. So it's your responsibility to make sure that you give them the best return of investment. Again, it's an advert for your company. Moving on, Kim. Yeah, so product selection is very critical. You know, you've got to get the right balance. You've got power generation from your PV, you've got the storage size of the battery, and you've got the energy conversion by the inverter. So that ratio has got to work nicely. There's no point in having a battery which is never ever going to be full from the small array that you've got. You've got to make sure that your array is going to be filling the battery and obviously providing power during the daytime, and your battery's got to be able to run for whatever hours you set it with. So the ratio is very important. I mean, what we find is on a lot of our sites, many sites, we have people who, you know, they end up with having a little bit more money to spend, maybe after a year or so, and they say, add us one more battery, please, or another couple of batteries, or put more panels on the roof. And that's where it's important to, you know, maintain your ratios. Sure, we can add more batteries, but then we need to add another 12 panels or whatever. So it's important to get that ratio correct and let them understand why. You know, there's different brands that do slightly different things. I mean, you get expensive, you get cheap, you get medium. Make sure that the brand that you're putting in there is one that you want to be putting in there. You don't want to be going back to site backwards and forwards because it's not working perfectly, or there's some funny little idiosyncrasies on that particular model that you haven't been able to, work properly. So we tend to stick to two brands. We've got a battery inverter brand that we use almost all the time, and we've got a grid-tied inverter setup that we use almost all the time. We stick to those two as much as possible. We know how they work. We know how to program them. We have a very good understanding of troubleshooting on them. So, if you can do that, if you can become an expert in the model that you're using and the brand that you're using, whatever brand it is, try and become an expert in that, because you are, like I say, you're going to be putting that in. And remember, on a site that you install a system on, it's not like you're going to say goodbye, everyone, see you next year or a couple of years time. You might be there many times. You might have this couple, this house, they might be, pretty close to you for the next 5 years. So you've got to make sure you understand what you're putting in there. Okay. So, Michael, the question there, what inverter battery brands are recommended? Look, we use Victron and we use Solar Edge. It's obviously, for us, those are the ones that work very well. There's a price difference between them and a lot of products that are on the market, but we like them because we understand them. So it depends on what you use. There's a chap I was talking to yesterday. He uses Fox ESS and he's just in love with it. He thinks they're the best thing that's ever happened, and good for them. That works for them. So like I say, it's not only, there's not only one way of doing things. There's many ways to do it, but you've got to be responsible for it. Okay. So now we come to the installation. Everyone's happy with the quote we've given them. They're not always, but let's say they're happy with the quote that they've received. They understand what you're going to be doing. They have a very good understanding of what the system will be able to offer them and how it will work, and what possibly it could save them. So the next step is the installation. They've given you the go-ahead. A lot of local authorities, they want you to apply for an SSEG application. We do it in the city of Cape Town straight away. There it is. And sometimes, we're installing while we're waiting for that application to come back to us. But generally, we're not going to put an application in that we know is not going to be accepted. So, but you've got to do it. It's part of the process. Then we split our installation into 4 groups, and we normally have 4 different teams that work on the different groups. Obviously, we've got somebody who does Kim. Switch the button. Yeah, there we go. AC wiring, of course, we've got our electricians. They come in, they do the AC wiring, the DB preparations, and when you've got a backup system, the DB preparation is critical. I mean, you've got to be building a backup circuit as well, a backup board. The changeover switches and all the legal parts that's required for the SSEG applications. You've got your connection to the grid. That's all the AC. Obviously the AC cable and the wireways are very important, that they're nice and neat. Then we've got the battery and the inverter. That's got to be done by, well, we like to use a couple of guys are very good at making something look beautiful. So we use those guys for the inverter and the battery installation. They do a wonderful job, nice and neat. And PV panel array, we've got guys on the roof who have been doing it for years. They make sure everything is straight, everything is perfect. And the cabling, the DC cabling is critical as well. We use sometimes Bosal, sometimes we use a metal trunk that we develop, sometimes we use other methods, but everything's got to be done correctly. And the 4th group that comes along and does the communications, which is highly important. I mean, with that, if that 0.25 millimeter copper cable isn't sitting perfectly in that bloody jack, then nothing works. So comms is very, very, very important. So of course, your sites, obviously they've got to be technically correct. They've got to be neat and tidy. And your panels need to be aligned nicely. Somebody's going to be standing back on the street looking up at the house roof and looking at it and saying, oh, wow, that looks wonderful. That looks nice. The way that it's laid out is great, and I'm happy with it. Or if it's not, it's going to stick out like a sore thumb. So make sure everything looks really, really neat. We have a pretty strict site everything's tidy on the site. We don't have bits and pieces lying all over the place. Everything's permanently cleaned up so that when the client walks around and has a look, you can see that we're doing a nice, neat job for him. Okay, Kim. Technical compliance. I mean, you all know you've got to be compliant in your installations with SANS. These are not recommendations. These are obligatory. You've got to do it correctly. It's not only because it says so, it's because it's a safe way of doing things. That's why it is a standard. You've got to use a qualified electrician. You can't just have anyone come along and put your cables in. Your electrician is going to be the one who's giving you a COC, so you need him. PV installations have to be earthed properly, guys. Like bonding of PV panels and rails and everything's got to be done properly. Very, very important. I mean, when somebody's doing an inspection, I promise you that's one of the first things that they look for. All your labels need to be done according to SANS as well. You've got to have labels everywhere. I mean, we put labels on everything, DC, cable warnings, the lot. We make sure that we over-label the whole place, just because, again, when there's an inspection, if they come along and they see one silly little label, they just walk away and say, see you later. Come back and when it's done properly. So we do everything like that. And sometimes, you know, with an SSEG application from the local authority, you may need an engineer sign off, not always, but we do quite often. And the engineer is going to arrive on site. It'll be somebody that we appoint an engineer. He comes on site. He's going to pull out the single line diagram. He's going to look at what you've designed. He's going to make sure that it should be, you know, that's safely done. And he's going to check everything. And if it says there's a 40 amp breaker there, there must be a 40 amp breaker there. If it says that cable's 16 mil, it must be 16 mil, not 4 mil. You can't believe how many times we see that on some installations that we have to repair. So guys, you know, doing a good job is going to save you a hell of a lot of time as well, and money. Kim? Yeah, you know, if you're feeding back to the grid, of course, you've got to have an agreement with the local authority. And in some cases, even if you're not feeding back, you've got to have agreement. City of Cape Town require you to sign an agreement, a contract, when you connect to them, whether you're feeding back or not. I don't know what it's like all over the rest of the country, but that's what it's like here. The PV green card. Wow. I have to say, this is one of the nicest tools that we use. It's very, very helpful when it comes to, certainly for, you know, a residential installation probably has the same amount of moving parts as a commercial installation. Sometimes more because you've got batteries and you've got all sorts of other bits and pieces that you don't have on a commercial. But the PV green card, while you're on site doing what you need to do, you have to, you know, record everything. Take photos, take as many photos as you possibly can. Take serial numbers down of every single part that you're using. It's a record of the whole installation from start to finish. And it's great because you yourself might go back there in 6 months' time, and you know, if you haven't recorded everything, if you have, you've got to be able to, you know, you can't remember everything. You've done another 30 sites since then, so it's very, very handy. And of course, you know, sometimes it's not you going back there, it's somebody else. So they need to be able to access the information. They need to look at the single line diagrams, how you've strung the panels together, how you've laid everything out. And if there's something that they've got to repair, it's much easier for them to have that. Of course, you know, for the PV green card, you might need, you know, you might need it for funding. You might find that the client is borrowing money from a bank in order to fund his installation, and one of the requirements from the bank is a PV green card. So that makes sense because banks don't like to lend money to clients if they feel that it's a risk. So with the green card, that alleviates that risk by some way for them. And obviously, yeah.
Just noting we've got 2 minutes left, yeah?
2 minutes, quick, let's go. Kim, go.
Thank you.
Next one, Kim, handing over. Right, so when you hand over, this is what we give our client. We give it in a nice thick folder. We also give it in a PDF format. All the manuals of all the parts that we've put in, all the inverters, everything. Line diagrams, warranty documents, specification sheets, access to all the portals, COC for the work, the PV green card, application approvals. We do a site model, 3D site model, showing them where the panels are. And of course, instructions. We do a whole instruction on how we shut everything down, what the bypass switch does. Sometimes people forget that they have a changeover switch. So you need to explain that to them. Next, Kim. Yeah, so performance of a system. Now, obviously nowadays, there's many brands have a good portal and a good method of being able to look at what's happening on the system. So this is the way that your client will catch you out if you've been lying to them. So make sure you've done a really good job and you've given them what they've asked for, and you've given to them, exactly what you say you would have done. And this portal, this little app that he's looking at on his phone is, honestly, it's like handing out a business card to somebody. He'll be sitting in the pub at the golf club showing all his friends what he's got, and he'll be boasting about it. So that's exactly what you're doing. You're giving them a reason to get hold of their friends and show them what they've got, what he's got, what they need. Troubleshooting, of course, with the different portals, you might find it easier to troubleshoot. But obviously, if you've done your PV green card, you've done your SLDs, you'll be able to find ways and understand of how to fix things that arise. Again, if you've been working with that particular brand for a long time, you should be able to troubleshoot quite easily and effectively fix whatever the problem is. So that's basically, residential installations in a nutshell. So thanks, guys.
Fantastic. Thank you so much, Greg. And yeah, I think I really appreciate the level of detail you've given. It'll be quite useful as we go to the bigger scale projects. I think the fundamental will remain, so we can get into further detail as we get bigger scale. I think just to rehash a few of the fundamental things which you mentioned, which is the processes around the legal and regulatory requirements. It's so critical that we follow those. They can be seen in two different ways, but what they really are is to ensure the sustainability and the responsibility of our sector, and therefore its continuity, but also ensuring trust at the end user, that they can look at somebody who has a PV green card accreditation and know that that's something they can trust, or they can take it to the bank and know that they can get funding for it. So it unlocks so much more for the sector, which is why it's so important. And I think what you mentioned around doing a good job. It's obviously a business basic, but I think it's something to really, really emphasize, because I, for example, have recommended a service provider on my PV system to somebody just because of the experience I had, how much detail they explained to me. So it's absolutely crucial for businesses to do that. So yeah, thanks a lot for that, Greg.
Thank you.
So let me move right to the next speaker, De Villiers Botha from SolarF, who will be looking at your commercial rooftop solar PV installation. So without reading his very, very extensive profile, I just want to say that I serve with De Villiers on the current SAPIA Management Committee, and he is a phenomenal resource. I thought he was an engineer, and then I also heard him talk about legal matters, and I think he's also either a lawyer or an advocate or an attorney. I don't know which of the ones he is, but somebody who's been in the game for such a long time, both in solar PV, but also in electric vehicles, and he brings a wealth of experience in the sector. So to take us through commercial rooftop installations, over to you, Dev.
Thanks a lot, Maloba. Yeah, good afternoon, everyone. And I think you just mentioned a very, very important S word, and that's not solar. It is sustainability. And I think in most projects, and Greg, thank you very much for that introduction. Your regulatory aspects that you touched on was perfect, flowing into my ranting about it, if I could even go as harsh as that. But it is to say systems need to be compliant to be sustainable, so that they will last. We need to ensure there's financial sustainability of the system, so the clients, and I'll show you a bit later how the grid matching and the use of power is to be considered. And also the sustainability of the supply chain. We know currently there's a matter pending before the courts regarding local content, and it's a matter between some of the large module manufacturers with regards to the procurement in the large IPP rounds, but it's the sustainability of the supply chain, and then also the sustainability of your supporters. You can call it the Greeks and the De Villiers of the world, and the Kates of the world are the people that built your system, the EPCs that built your system. They're going to support your system through that. And all of that has to be sustainable. Now, what we've seen is very often, especially on financial sustainability, there was also a lot of pressure on manufacturers, driving prices down. I still recall the days when we said it's going to be a bargain to buy modules at 65 cents. We're at less than half of that now, and it's actually on a slight upward trend. So it's really the sustainability of those suppliers. Now, important then to make sure that, first of all, as Greg said, we are compliant or technically compliant to have a sustainable system. And that's perhaps what this slide touches on. I'm not going to repeat what Greg touched on, but how I split it always is to say you have administrative rules and you have technical rules. An administrative rule is typically a piece of paper. Okay. If you haven't registered your system with NERSA, importantly, that part, or did not fill in the form, it doesn't mean the house or the factory is going to burn down. It does mean, yes, you did not comply with the regulations that require you to register that, and perhaps to give those resources to government to do the planning thereof. So that's the administrative part. The technical part, however, is not negotiable. That's what Greg touched on, the NRS 097s, the grid code, SANS 10142, and the likes. And that is essentially, if you look at the right-hand blocks, the red blocks, that's where our utilities and our municipalities come in, the grid operators. We have to, and it's not negotiable, register our systems with them. Yes, some of them do have a bit of an administrative backlog. Some of them do take 6 months to respond. Some of them take 72 hours to register your system. But we have to go and do that, because if you don't do that, you are technically an illegal connection. You are just like the guy who connected straight from the transformer pole into his house. That's important. And then lastly, also, as Greg already mentioned, how you put your system together regarding your component, switchgear, and protection devices. If we then go to the administrative on the left, the blue blocks, moreover, we start with Schedule 2 of the Electricity Regulation Act, and perhaps rather start with the Act, which says all systems has to be licensed and registered unless you are exempt. And that's in where Schedule 2 came in. And we know that in August, Schedule 2 was released, where we now have the 100 megawatt licensing limit. So I'd say that very few systems in future is going to require licenses. The larger plants, which would be more over the Eskom large coal generation sites, and if car power ships or the likes of the risk mitigating systems come online, some of them would exceed the 100 megawatt threshold, and they would need to. But for our purposes, I think, especially even on thinking of 75 megawatt solar farms we know existing in the Karoo, very few licenses will have to be issued. But registration is a reality. Registration is required for each system larger than 100 kilowatt. It's registration directly with NERSA. It's only a 200 Rand fee at present. There was a bit of a stall in that process, but I've actually gotten an hour before this, I got confirmation direct from NERSA that the registrations are not stopped, because there were rumors that the registrations have stopped pending the Schedule 2 needing to be fixed, because there was a slight, call it drukkersduivel, as they put it in Afrikaans. There was a misprint where the bottom of the pages were cut off, and it was said that NERSA is waiting on that finalization before any registrations proceeded, but that would have been against the spirit of us being an energy poor country. So I confirmed with NERSA, the registrations are proceeding. So you have to register those systems with NERSA. It gives the country and it gives industry access to data where we know how to plan these systems. And as I said, yes, if you don't register, the building's not going to burn down. But yes, it's the right thing to do. Thank you, Kim. So I'm going to step off from regulation now and go to a bit of a case study. And Apologies, what I've got there is Clearwater Mall, and it's a nice commercial system to showcase, and for various reasons. Firstly, perhaps again reiterating, for council involvement. The reason why the mall invested in solar PV to start with in 2014 was for purposes of expanding their electricity consumption from city power. So city power could not supply more power to that site. In the area where that mall is situated, there is simply no more power available. So Clearwater Mall had to make a plan. And initially what we built is on the right-hand side of your screen that, well, on this picture it seems little. I'll call it a little block for the current purpose. But that was the initial 500 kilowatt peak system comprising 4,000 square meters on the parking roof. And that was built into, it was commissioned in November 2014. Now, just to think technology for a moment, pausing there, most of you that now buy modules would think of buying a 450 or a 540 watt module. That system was built with 240 watt modules. That was the standard 60 cell at the time. Yeah, 7 years ago. Time flies, eh? So that just shows you. We then switched on the system, and the reason, and I'll get to that after these slides, you'll see that. And the reason why a grid-tied solar PV system would work for them to expand their consumption was because of the largest consumer in the mall is the air conditioning. And an air conditioning works harder in the longer summer months, and that's also usually when you have quality sunshine, and then what we can call the air conditioning load match. So you didn't need a battery to expand that, all right? But then at the time when we commissioned that, the mall said they will take a 6-month view. However, on the 4th of March 2015, they placed the order for the next megawatt, and that's the 2 blocks you see on your left-hand side of the screen. That was then commissioned by September 2015, and that was also the first time that a rooftop surpassed the 1 megawatt mark. And what we did then is to engage NERSA and see how are they going to handle it, because we know we are then surpassing the NRSs. But at the time, the Schedule 2 said all consumption for own use, and it was exempted on the basis that the mall consumed all the power that is generated by these panels. Remember, that's what the schedule then said. All right, then the next phase, Kim, you can slide on there. So then in 2017, we did the 3rd phase where we filled up the gaps. So what you see on that roof are 3 different module manufacturers and 3 different module sizes. Now, importantly, where I started with, and what I'm glad that my previous speakers raised, is the sustainability word. And I'll call names because we know some of those factories aren't around. On the right-hand side, far right-hand side, phase 1, you had Solar Direct. Then we had Yingling on the phase 2, and phase 3 was Canadian, is still Canadian. So we know that Solar Direct is not, well, at that time they had a lamination factory in the Cape, and it closed down. And it was moreover because of, call it the IPP rounds that didn't happen as fluently as we would have all liked, and these factories based their investment cases on those. So also what you have here is you have 60 cell 240 watt modules, but you also have a, if I recall correctly, a 350 or even higher 400 watt 72 cell type module in that range. But still, it doesn't look too bad, I think, especially from far away. And then again, no one ever sees this roof unless you go to the mountain. So it's not one of those systems that you do see every day when you pass that, to realize that there are actually different size modules on these roofs. And that's what people sometimes ask. They say, well, should I not buy now and wait for my next technology? It's like saying I'm not going to buy a Pentium 2 computer in 1998 because I'm waiting for the iCore 5 in 2021. But what would you have done since 1998? So, you know what? No, the day to invest is when the business case makes sense, and that is now. Don't wait for the technology then. But what you could do, and we've seen it now with other clients, is that they say, you know what? Our roof space are limited, and as you can see, this roof is now filled up. Let's move on to, let's see whether the fitting new modules would make sense, because we know they became more effective per square meter. And then you could run those numbers. And we actually do have one client in the Western Cape where that is the case, and we are removing modules from a roof and fitting newer models, because still it makes financial sense. The numbers balance. So important here, we took hands with City Power in this instance. City Power has themselves showcased this system as an opportunity where the solar PV and grid-tied solar PV is not a revenue loss to them, but actually a revenue gain. The reason there was because of the increased capacity availability of the mall now due to this, they could add square meters. They added some shops and GLA, what you call it, bricks and mortar stuff, which the malls are good at. And now they have the evening consumption in the peak times that they pay to City Power because of the solar system generating during the day. So it's an example of taking hands with your utility and not just sidestepping them, where it actually creates opportunity in taking hands. So we can move on, Kim, to the air conditioning effect. Or sorry, this is just the effect of the system, if I could put that first. So what is important also in the assessment of your commercial client, similar to what Greg touched on, is to say, are you a 7-day or a 5-day or a 5.5-day operation? So the luxury of most shopping malls are that they are 7-day operations. And this is what your load versus the consumption would look like. So the load is the top line, which includes the gray area. The orange is the PV generation on a nice, fully sunny day with a good D curve or bell curve, depending on the way you interpret the shape. And then the blue shows you the consumption now being drawn from council. And you can see it actually flattened the consumption from council now. So in the mall's case, it is actually good also for grid stability when you speak to your municipality about that. Thank you, Kim. Yeah, then also something you cannot measure through a meter is what I call the tropical cooling effect. Some of you that are older, and I was one of the youngsters driving one of them, is the old Series 3 and Series 2 Land Rovers, which had a tropical roof. So it was a lining that went over the roof, and as you drove, the wind blew underneath that, and that was your aircon, except for the little dash openers. And this is the same effect we find on these systems. If you measure the temperature below the roof, in this instance, you'll see there's a 9-degree reduction that you find. We've seen other sites where you can get up to 25 to 30 degrees of reduction in temperature. And that makes your air conditioning work less and all of that. But you cannot measure that. So that's another added benefit for commercial systems, that you effectively now put your roof in the shade. With that also comes the opportunity that your roof will require less maintenance in the long term because the sun doesn't burn it anymore. However, before you start, make sure that the roof is properly painted and covered so that you don't now, after 2 years, realize, oh no, there's an old problem that wasn't fixed before we fitted the PV, and you then have to remove the PV to fix that also. Just an important note there. Thank you, Kim. All right, now I'm going to show you someone where you might think it doesn't work. So a mall, we know 7-day operation. You have your air conditioning load match. So every day will look as what I've showed you before. So what I've got here is a winery. They are seriously seasonal. And you'll see through these slides. I think what's important here is to look at, this is harvest season, the current that I'm showing you. And you'll see this was taken on 17 March of this year. Important to look at what their peak consumption is around just before 6 in the afternoon. You'll see they're just around 700 kilowatts is what they draw from their municipality. And you will see down here the yellow, that's the solar system generating. So it's a 100 kilowatt solar system that they have in this instance. This is their harvest season, and they've got 3 months of heavy consumption, and they have 9 months of much reduced consumption. And now the question is exactly as Greg said on residential systems. How do you design the optimal system for this client? And the better way to do that is through getting active data from the system. You do not want to over-design this, because then the client would not have the financial benefit. And again, I'm back at the sustainability word. They would not have the financial sustainability that they foresaw the system is going to bring about. Kim, we can move to the next one. So this was July of this year, the same plant, but you will see the maximum was hit just at around 11 in the morning, but only call it 147-ish kilowatt at the time. So from 700, the demand dropped down, max demand on that day to that. And on this day, you can see they consumed still all the power because the load is shown by the black line. The solar was a nice, perfect sunny winter's day then, obviously. And all the consumptions then remained, well, all the generation were consumed by the site. We then move on to the next one. And here you see January. This was still basically when they were all on holiday still, a very low load. I think their peak was around 10, 15 kilowatt in the day. At night, it sat at 5 kilowatt. It's similar to a residence. And what you see now here is that the same 100 kilowatt system almost peaked out at 100 kilowatt. And the blue below the line shows you that they fed back to the municipality. So as Greg also said, you engage with your municipality, and in this instance, there is a feed-in tariff where you could then plug in the feed-in tariff according to the data you then have of this client, and then look at the solar generation and see how over a period of a full year, you optimize and design the system. So if you've taken a winter load, or sorry, a harvest load, you would have said this client needs a 700 odd kilowatt system, which would have been totally oversized for a feed-in tariff where you only get paid 52 cents. But if you went to a 200 even for the winter load, the July load, you would have also had the same. So that's why it's important to take a full consumption, and more data you get, the better, and then build the system according to that. Thank you, Kim. Yeah, and I think that is the short story for today. I'm happy to answer any more questions also later on. I know we've got colleagues that also want to speak, so I think we'll cover nice subjects today.
Fantastic. Thank you so much, Dev, and perfectly timed. Yeah, I really like the points you raised around, you know, the complementarity, if that's the word, between what solar PV has to offer, and not just what clients need, and not just sort of clients' demand or consumption profiles, but also the municipalities, right? So moving away from this mindset of these are kilowatt hours that the municipality is missing out on. I think there's such a variety of business cases that when we go to clients, we need to look at it and say, where are you? What are your needs? What are the needs of the municipality? How do you find a win-win situation? But also, how do you design systems appropriately, right? So if you're in a municipality that you can feed back into it, consider that in your system design, put that as a business case, offer it to the municipality, offer it to the end user, and design a system that meets all of that. So that's really, really exciting to hear. I'm sure we'll get a few more questions on that. Yeah.
I mean, that's what distributed generation, being the new term, is all about. We used to have the vertical system of Eskom on top and us consumers at the bottom, but we are now going to become a spider web of generation and consumer assets, and that's what distributed generation means. Yeah, that's going to be there.
Absolutely. Fantastic. And I think it's quite fitting at this point to bring in Kate in a room full of engineers, AC, DC, NRS, a whole bunch of technical terms, somebody whose expertise is to communicate these things effectively, and working in this space, you know, for the past 8 years at one of the, well, a very successful renewable energy project company in South Africa, you know, to talk us through your, you know, your ground-mounted PV system. So we had residentials, smaller scale systems, we had rooftop commercial systems, and now we move it to the ground, possibly bigger systems, more complexities now as you connect your system to the load, and just to walk us around the fundamentals of that. Kate, over to you.
Thanks so much, Maloba. Good afternoon, everyone. Yeah, so as Maloba mentioned, I think it's a great segue from De Villiers' presentation into mine. Essentially what wheeling is, and you know, I'll be speaking about utility scale PV construction, but how that links into wheeling is this idea of a distributed generation grid. So I'm focusing on the fundamentals of energy wheeling, but also on the sort of aspects of building a utility scale PV system. And as Maloba mentioned, I'm not an engineer, but I do my best to communicate things. So I hopefully will be able to answer all the questions. Yeah, so from a solar side, which is who I'm representing, we are a vertically integrated solar PV systems company, and we have experience right from project development through to construction, design, and operations and maintenance. And we've developed a number of large-scale utility solar assets, around 338 megawatts worth. We've deployed our own capital, 270 million into those assets. We've also built about 99 megawatts of C&I rooftop systems, and we also have about 81 megawatts of those that are currently under our operation. So just to give an idea of some of the different activities that we focus on. Next slide. So I think I'll ground this conversation in wheeling, because the idea of building a utility scale PV plant is really reliant on the wheeling framework. Unless you're participating in a government IPP program, essentially the method through which you're going to be building a utility scale PV plant is through a wheeling agreement. So wheeling essentially has three different components, or three different parties, I should say. On the one hand, you've got your solar PV facility, and that is the party who owns and creates the energy generation. And on the other hand, you have the client who actually is the off-taker and wants to use the energy. And in the middle, you have Eskom, who facilitates the transaction. Next slide. So before we start, I guess, to think about the topic of today and linking it back to construction and the fundamentals of building these systems, there's some very important considerations to take into account when building utility scale ground mounted projects. So the first is obviously that utility projects are much larger. So there's a lot more considerations. Obviously, actually, the presentations that have led up to this are great because the fundamentals are really there, starting with obviously the quality of the design of your system and the way in which you build it, right up to the regulatory aspects. But the utility scale projects are essentially on a much larger scale. And so there are many more considerations for these projects. So the first is location. So the nice thing about wheeling is that the PV generating facility does not need to be near the energy off-taker or the client, which means that you can benefit from using an area that has really high irradiation and is maybe easier to build or remote, where you can lay out a lot of panels in a larger area. But one of the very important considerations is this idea that the location of your PV plant has to be close to an Eskom grid tie-in point or substation with enough capacity to allow yourself to input into the grid. Next point, Kim. Oh yeah, so that was the next point. Obviously, you need to be close to that. The second point when it comes to building utility scale systems is the development. So in addition to the design, which you would typically have in a residential or a C&I project, a ground mount utility project needs a development phase, which is obviously permitting the land in specialist environmental and land use studies and gaining. You might need to subdivide the land, for example. And the second will be geotechnical studies, which will need to be completed in order to understand the ground conditions, what the wind is like on site, what the soiling is like, and all of those kinds of things that will actually affect the output of your solar system. And then the third important aspect of development is understanding aspects of skills development or community upliftment. Often they are part of the project commitments that you take on when building these projects, but also it's just a really nice way in which to make the overall project build mean something to the local community and actually have longer term economic impacts for the community in which you're building. So as a rule of thumb, or as a sort of idea, Obviously, each different utility scale project has a different size, and it'll therefore have a different timeline. But as a sort of rule of thumb, if you're building a 100 megawatt system, you require around about 200 hectares, and it'll take around 2 years for the development phase, and then about 12 months to construct. So that's just to give you an idea of the amount of time that one needs in order to construct one of these projects. Next slide, please. So as I mentioned before, the wheeling has 3 different parties that are involved. If you can just press for the first point, Kim. So the independent power producer would be yourself if you were taking on a project like this. Basically, they take on the costs relating to the solar PV facility, and they typically maintain it and maintain the ownership of it throughout the life or the duration of the PPA. The second party is obviously Eskom. They permit the wheeling and the sale of electricity into their network, and they charge a network connection and a wheeling fee. So interesting to De Villiers' point on the mall that actually fed in their to the city of Joburg in terms of their demand charge. This is a similar thing where you're actually paying Eskom to use their grid and therefore offering a new stream of income to Eskom, which is why wheeling is such a feasible and really exciting upgrade to the way in which we can procure power. And then obviously your last one is your off-taker. So that's your client. They will receive a reduction in their overall electricity bill based on the amount of electricity that the power plant has generated. And they pay 2 fees at the end of the month. They will pay their reduced Eskom amount, which will be their normal sort of amount of electricity they've consumed during the month, minus the amount that the wheeling project has produced. And then they'll pay a independent power producer bill as well. So they get 2 separate bills at the end of the month. I've included on this slide the various different agreements that are needed in place. So there are quite a few different agreements. There needs to be agreements between the IPP and Eskom. There also needs to be agreements between Eskom and off-takers, and then obviously the off-taker and the independent power producer typically start with a power purchase agreement. Next slide, please. So some of the legal considerations, and this links to the importance of sort of regulatory aspects that we have been discussing. Eskom does have a wheeling framework, which has been in place since March 2011, and it's governed by lots of different conditions, such as Eskom's bid code and NERSA licensing, etc. And Eskom is taking a very positive, and in our view, positive stance toward energy wheeling and actually trying to really build the idea of people paying to use their grid and use the transmission lines into their transmission business, which will be one of the unbundled businesses of Eskom. Obviously, NERSA currently is licensing generators under the IRP. The IRP allows for the allocation of short-term capacity and energy gap provision, which is unlimited until 2022, and thereafter it's limited to 500 megawatts per year. So also building these really large plants at the moment is something that we're trying to get as much done before 2022, and then thereafter it'll be 500 megawatts per year. And then obviously we are happy with the ERA 2 schedule amendment, which basically means facilities under 100 megawatts don't need the generation license, but they do need to register the project. So yeah, those are the legal sort of aspects. I've spoken a bit to this already, but the wheeling timeline. So this is sort of an idea of what 3 years looks like. I know that the gray writing is quite difficult to see, but essentially in those first 6 months, what you have is the appointment of the electricity consultant and the RFP. Typically, this is a process that is driven by the client and driven by their requirements in terms of procuring renewable energy and what they actually need. So the bidding process and actually getting the RFP awarded will typically be what's happening in the first 6 months. Then it'll be about 4 months, optimistically, 4 months to get the PPA agreed and signed. There is a bit of PPA negotiation that always happens. It usually also needs some more detailed design work in order to understand how much the plant can output, etc. And typically these things affect the PPA and the way it's arranged. So that negotiation process can take quite a long time. And then once the PPA is actually signed, you can get started with the project approvals. And that's what I was saying before about all of the development work that needs to happen. The permitting of the site, the environmental impact assessments, and getting Eskom's budget quote, which will essentially be Eskom's rate at which the wheeling energy can be supplied to the grid. So once that process is complete, then you reach financial close and you can actually begin construction of the plant, which, as mentioned, takes about a year for a 100 megawatt plant. So just to give you an idea that it is a very long process, but if you are able to permit your sites in advance, it can potentially be speeded up a little bit. Next slide, please. Yeah, so if you can just press the first button, so that block comes up. Yes. So as I've mentioned before, there's three fundamental components. So the first is site development, and I've spoken about this quite a lot, but it's important that you remember that for utility scale or ground mounted projects, you need to do topographical studies because the ground that you're building on is essentially your rooftop. So in a C&I project, you would need to do a structural assessment to understand if the roof can take the extra load. On a ground mounted system, you obviously have to do a topographical study to understand what is the ground like, how's it going to move, how deep do we need to do our trenching, etc., etc. Next point. Then it's obviously the project design phase, and now this is quite a complex phase, but you take what the client's energy requirements are and translate that into a viable project. And that goes with understanding exactly how much the project needs to output, your different components that you're going to use, and appointing different consultants for external evaluation or external validation of the project design at the end. And then the final aspect is obviously the construction of the project. So one thing to note about utility scale PV construction is generally the supply, because the supply of components is so high, it's very important that the RFP process for those components is carried out quite early, and that those prices, etc., are agreed in advance, because those contracts are crucial to not only the sort of timeline of the project and whether you face delays, but also the overall profitability of that project. And then if you look at the actual construction components, sorry, Kim, just to finish that off, you'll just see that there's a few other layers to construction as opposed to your residential and your C&I. You'll obviously have to build roads. You'll probably have to have land leveling. You might need to construct offices and housing for the O&M teams. Then you'll obviously go onto your cabling, your modules and your trackers, etc. And then finally ending up with your commissioning and your Eskom grid connection. So that's it. I feel like I've gone very quickly and said a lot of information. So we have quite a useful wheeling page on our website, which explains a little bit more about wheeling projects. So I've included the link there. And you're also welcome to reach out to me for more information. And we are launching a wheeling project actually very soon. So we just keep your eyes peeled for information about that. And also we'll probably be doing a webinar on that as well. So keep your eyes peeled for more information if you're interested in wheeling. Thanks.
Absolutely fantastic. Thank you so much, Kate. And I was going to say well put, but that's just you doing your job. So thanks. Yeah, I think it's fantastic. Just for me, I think the highlight for all our participants is, once you get to this scale, the complexity obviously increases, but it means also the preparatory work that you have to do becomes quite significant. And that speaks to becoming aware of what are all of those requirements, what are the wheeling regimes that you're going to have to engage in, what are the wheeling contracts that you need to have in place, what's the substation capacity where your site is, Are you wheeling through Eskom only? Are you wheeling through Eskom and one municipality or two, God forbid? All of those considerations before you get anything started. And this is probably going to feed into your business case with your client as well, to say, cool, if I'm here and we're doing this, this is how this comes into the tariff, and it dictates what you can offer that client. And then also just being aware of that means that once the client have said, cool, let's go, that close period isn't hindered by the regulatory work that you maybe hadn't prepared for already. So yeah, very, very insightful. 3 years shrinked into one slide is quite something else, but a lot of work. But I'm assuming, also very, very exciting projects to get involved in. So thanks for that, Kate. I think before we wrap up, or rather we get into the Q&A, just again, like we said in the beginning, the specific webinar today is sponsored by Trina Solar. So, just to give thanks to them again, and also to bring in Lawrence Vermaak, who's the sales manager for the Africa region, to give us a few words, maybe introduce who Trina Solar is, what you guys do, but also your space in your role rather in the distributed generation space. So Lawrence, over to you.
Thank you, Malobo. And yeah, welcome to everybody once again. And thank you for giving us the opportunity to present our technology. Right, so Trina Solar has been around since 1997. Sorry, Kim, if you can just go back. Sorry about that. Yeah, so we've been around since 1997. We've got 14,000 employees. We presented in over 100 countries. We've distributed over 60 gigawatts worth of solar modules since inception. And doing really well in the embedded generation at the moment. So yeah, Kim, if we can go into the next slide. So looking at embedded generation, we obviously need to concern ourselves with what our EPC clients or our installers or our utility scale clients are looking at, and we've identified 4 factors that we think is important and that we are focusing on as a company. One of them is the investment security. We obviously need to make sure that we produce or we supply a product to the market that's going to be investable. It's got to be something that is going to be attractive to the investor or to a bank or to any funder at that point in time. We also look at the quality and the technology that we produce. We also look at cost reducing the capex, and then the impact in the environment. As we're well aware, there's a talk going on at the moment that we need to start looking at recycling the modules, because we are entering an era or a stage where recycling of modules is very important, and it's something that we need to start looking at. So we are also, through our technology and advantages of our technology, we are looking at this factor as well as a very important point. Kim? Right, so investment security. One of the top things that an investor looks at is how bankable a company is and how bankable is the product that he's going to invest in. Trina Solar is one of the proud companies that can say that we've been bankable, or the top bankable company, for 6 consecutive years in a row. A lot of suppliers can say that they're bankable, but for a supplier to be bankable for 6 times in a row, and we're heading for number 7 very quickly, this is an important factor for any EPC investor or funder or IPP to look at, because it shows that we manage our finances well. We manage the way that we do things is lean management, financing. We don't sell at a loss. We always make sure that we are available to stand by our warranties and our guarantees, because as you know, a module or a project, you've got to promise or sign off warranties and guarantees for 25 to 30 years, and this is an important factor. So if I'm going to sell, or Trina Solar is going to sell a product to a client, and we're not around in 5 years, then and something goes wrong with the products, then this is something that you're going to end up having a headache, or the consumer is going to end up having a headache with. Kim? And then when we move on to quality, which is the second point or factor that we look at, quality is something that we take up very seriously. We were the first company to receive the UL's Client Test Data Program certification, and this was awarded to us because of Not only our 25 to 30 years product warranty on our products, but we've also increased, our workmanship warranty up to 15 years. All our data and certificates, data sheets, PAN files, all of those things are third-party verified and certificated, or certificates are given for it. So when our clients are asking us for a data sheet or a PAN file to optimize the system, we know that it's been third-party verified and it's true and it's factual. We also have overturned in process quality control checks. So from the point that the raw material gets into the warehouse and it goes through the production facility and it ends up in a pallet into the warehouse, there's just overturned in process quality control checks that we do. Okay. Not only do we focus on the quality, but we also focus on the technology that we bring to the market. And we've introduced in the last 18 months new technology, which is the 210 millimeter wafer. It's a larger wafer than what we are used to. If you look at the trend, about 2 years ago, the industry was working on 156.75 or 158 millimeter wafer. It then increased in about 2018, it increased to about 166 millimeters. And since mid-2019, we've all started looking at, Tuna Solar started looking at the 210 millimeter wafer. That is one of the advanced features of our technology. There's also the non-destructive cutting technology, what we've brought in. In the old days, we used to have high temperatures and a fast cutting method. We've now slowed it down. We've lowered the temperature and we've also lowered the speed at which the wafers are separated to create the solar cells. And basically what this does is it leaves you with a much smoother edge on a solar wafer or solar cell, which then offers opportunities for less microcracks at the end of the day. We've also introduced a multi-bus bar, which is we've moved now for our 400 and 500 watt modules, we've moved to 10 bus bars. And for our 550s and upwards up to 670 watts, we've introduced 12 bus bars. Now, the bus bars basically means that you shorten the path of energy transfer that gets generated or converted into energy or electricity. The high density encapsulation technology. In the old days, we used to have a 2 millimeter gap between the solar wafers or the solar cells. We've now minimized that to 5 millimeters, which gives us a high density inter-cell connection. One of the important factors that both Greg and de Villiers and Kate has also mentioned, it's very important for any IPP developer, EPC installer to carefully select their product that they're going to be using in any of their projects or installations. So Tuna Solar, with the new technology that we've introduced that I've just mentioned in the previous slide, has looked at what is needed for the residential market and what is going to be needed for the large EPC or large scale commercial, industrial, and eventually the utility scale programs as well. And this is what we're showcasing here is we've got the Vertex S, which is the 400 watt. It's a 1.75 meter tall module. It's the 60 cell format, if you look at size. And then we've got the bigger module for, bigger wattage. And then also, if you don't have space constraints, we can look at this sort of module. We also offer then the 550, 605, and 670 watt modules for the utility scale programs. Okay. So what we're trying to bring along to this conversation today is a study that's been done by Fraunhofer, Tuna Solar, and PV Tech Talk. We've announced this. I can send this to you guys if you. I can send it to Kim, and Kim can send it on to you. And it's basically it's a study done by Fraunhofer that looks at the different cell types. We're not looking at companies. We're not looking at any brands. We're looking at the actual technology that they're using. Now, the M10 is known as the 182 millimeter wafer. The G12 is what we are using, the 210 millimeter wafer, and then the M6 is the 106 millimeter wafer. And this basically, what this slide shows us is just the breakdown in capex cost, where you can see, there's a noticeable reduction in capex cost, not only with the wafer, but also with regards to the mounting structures, module transport, electricity systems, and also the civil works. These are all brought along by the fact that you can get higher power bins. You are installing less modules onto your site. which effectively means that you'll use less staff, less machinery, less space, all of those things combined together. Okay. We've taken this report as well, and we've showed you in the slides here that although this is in euro cents, because I mean we've got projects in South Africa, but the study hasn't been done in South Africa. It's been done by a German entity. But just on the capex alone, between the 182 millimeter wafer to where we are now today, 210 millimeter wafer at 665 watts, there's a 2.05 euro cents reduction in watt peak price on your total capex, and on your LCOE versus 182 versus the 210 millimeter wafer at the largest module that we've got, you're looking at a 4.1% reduction in LCOE cost. Okay. Okay, so furthermore, we've looked at the current technology in the market is the 210 millimeter wafer versus the 182 millimeter wafer. This is also on the same 10 megawatt DC plant that Franhoff has evaluated first. The number of modules is there's not a big difference between them, but when it comes to the DC cabling and the AC cabling length, you'll see that there's significant reduction in cost. And the same goes for the market. The rest of the guys that's in the market can currently only produce 590 watt modules, where we can do up to 665, and it gives you a significant it's almost 30 cents euro reduction in cost. Okay. Yeah, and then on the same site, we've laid down some details for you guys, and I think the biggest point to take away from this is, and this is where the recycling part comes in, is the G12 wafer technology creates an opportunity to reduce module installations or installation by 6,000 modules. Now we've based it on the 455, which we also produce. You would use 21,812 modules on the 10 megawatt site, but the new technology that we brought to the market now recently reduces that module procurement down to 15,252 modules, which is quite a lot. It's 6,000 modules that we don't have to worry about in the next couple of years to recycle as well. And that's it from my side, guys. Thanks.
Fantastic. Thank you so much, Lawrence. I think that was quite a fitting almost wrap up to this discussion, So, right from your small scale rooftop residential solutions through to your commercial rooftops, through to larger, distributed generation systems getting wheeled to customers across the country, there's a couple of fundamentals, which was the point of the session, right? Do it well, measure, understand what the client needs, understand and follow the regulatory and technical requirements, do a great job at it, and really look for the solution that works, not what do you want to sell. I'm sure De Villiers at Clearwater could have made a bigger system pitch to their client, but what is it that actually solves the problem? Because that kind of approach will lead to better business development, better relationships in the future. And I think from Lauren's side, there's a lot of high standard, highly technical work being done around technology development. And so as a potential player in the space, you want to follow Trina Solar, you want to be part of Sapia, and get to know what are the latest technology developments, what are the latest offerings that are available, what's competitive. If I have these limitations, either space or orientation, which technologies work best for me? And be able to reach out to the likes of Lawrence and other technology providers and hear what solutions they have, so that you're offering latest in class options to your end users. So yeah, thank you once again to our panelists. I think we can jump to a few questions and answers before our COO wraps up the session. I know there's a couple of questions that we've already answered and a few that are left here. Maybe to start with Michael's question, I think this was during Greg's section, which asks, do you typically conduct performance ratio testing on installation pre-handover? I think we could probably answer it at all three levels, right? So Greg, de Villiers, and yourself, Kate. Greg, you're on mute. It had to happen at some point.
Yeah. So on a small system, residential system like that, once we've done a design and we have a good understanding that that design that we're proposing should work, there's certain things that we can't control. And we need the system to be on. We need to be watching it for some time before we can even make adjustments to that. But there's certain things we just have no control over, and almost, well, I would say 90% of the systems we install need a little bit of tweaking here and there. So it's we don't like to try and test a system before we hand it over. We must hand it over, and we start our process of monitoring it for up to a month. We go back and we might change one or two things. It might be some board balancing that we have to take into consideration. So again, client relationship. They must understand your process. They must understand what you're going to be doing. They realize that you're not just leaving them to the wolves. You'll be back and you'll be making sure that you're getting their system running like a dream, like it should be running. Yeah.
Brilliant. Thanks, Greg. Anything from your side, de Villiers?
Just to say, on the commercial side, usually you have those performance guarantees, and it'll differ from contract to contract what the measure will be on what will be applied. But usually it's over a period. Some of them have a month testing period, some of them 3 months, some of them a year guarantee. It depends on the client and his, call it, exposure prior to the current project to the technology. I often joke and I say, well, one thing I now know after 10 or 11 years in the industry is that the photovoltaic electricity is not phantom power, it is real. So.
Brilliant. Thanks, de Villiers. Kate, from your side, I'm sure it's a very important role.
I was going to say it's an extremely important component of utility scale, to such an extent that we actually get it verified by external consultants. So it almost, with our C&I projects, we tend to do that in-house. We do performance testing as a standard measure. And like de Villiers said, it depends on the contract with the client. But at the utility scale, because there's so much more at stake in terms of the client, but also in terms of your outcomes, the performance is super important, and that often needs to be done even externally verified. Yeah.
Fantastic. Thanks, Kate. I think we still have a little bit more time before Nivesh comes to sum up. So while we wait for any further questions, just one that I'd like to pose. To a panelist that has been in the game for as long as you all have been and have seen so many changes, right? So I'm looking at you specifically, de Villiers, but I think everyone has also experienced the same, like from 2015 when 1 megawatt and below was allowed officially to now with the recent 100 megawatts and everything that has happened in between, right? Definitions, small tweaks in the wording, module price improvements, ESCOM price not improvement. What I mean, the trend is kind of obvious in terms of the growth of the sector, but what are some of those milestones that you've seen, and more importantly, what do we need going forward to really make sure that we take full advantage of the sector, and full advantage, if I can frame it as not just kilowatt hours on the grid, but I think there was a question asked around, inclusion into the sector. So the purpose of this kind of webinar, getting as many players, localized, Black youth, Black women in general into the sector. What are some of the things that we need to do in view of this market to really help have it, contribute to the just energy transition that we're talking about so often?
Yeah, I'll jump in with that perhaps. Yeah, the exact date of the Schedule 2 with the 1 megawatt limit was 10 November 2017. Any plants before that, and that's why you would have had the likes of the demo I had of Clearwater Mall, which was 2.9. So that was exempt because it was before that date. So from then on, all of a sudden, everyone got, I would say, afraid of the admin, or didn't want to do the admin of the license. So we had a lot of projects then being capped at 1 megawatt. And remember, the 1 megawatt in terms of the acts are always referring to the AC capacity. So you could overpanel slightly depending on the inverter technology used. So it's measured at the point of connection, what size will be tied in there. The opportunities that I often see, and especially with perhaps wheeling coming on board and so on a municipality scale, and I've said it many times, is that where traditionally in the vertical integrated electricity space, we would have sent our kids to university in the big cities and they would have gone on to work at Megawatt Park or on the coal fields in Mpumalanga. They will now stay at home in the town where they are, because there will be a generation plant built, and that plant will have to be constructed, maintained, operated, and those kids will remain there. So they could stay at home, call it that for lack of a better word, but they'll stay in their usual comfortable space. They don't need to go away and go and find an uncomfortable space where they now live far away from their families or kids or whatever the case is. The other opportunity is also that the distributed generation through wheeling will now mean, and I think Kate also touched on that, that your tariff, your wheeling tariff would just simply displace the municipality tariff. So municipalities will be either at the same or slightly better off than they would have been buying from Eskom. And important also on the transition is that it's not going to be that we overnight switch off Eskom and switch on renewables. It's going to be a transition. So what I'm always saying is that the current employees are going to retire in Eskom and their kids are going to be employed in the renewable energy sector. And the thriving power of a renewable energy sector is going to be that we're going to generate whatever technology, being agnostic on that, whether it's with storage, whether it's with wind turbines that could generate in other peak times, but we're going to generate, and important for us as a country, at the cheapest possible price. So if coal was cheapest, then for now, let's stick with it at certain times, or gas for that matter. But very soon we know storage and other technologies might overtake that. And when it happens, then we go with it. Sorry, there's quite a few principles I tried to throw in there.
Fantastic. No, it always goes to show your passion and your skin in the game in it, de Villiers. Thank you. Greg, Kate, who wants to go in first?
Go for it, Kate.
I saw you had muted yourself first. I assumed you were going to jump in there, Greg. Yeah, I guess just a point on the community development and the just transition. I think what's really exciting about wheeling as well is on the one hand, you're enabling large energy consumers to have power, excuse the pun, over where they procure their electricity from. And whilst in the past that might have painted a really bad picture for Eskom, the aspect of wheeling is that you pay for the use of the grid. And so Eskom actually becomes effectively a expert on energy transmission and the grid throughout South Africa. And that's actually going to be a much more affordable or much more cost-effective business for them, whilst we can also then provide cheaper power and more clean power, because that's a big consideration. I mean, we're going to COP26, and I think the government is going to sort of try and lock down on some of our carbon emissions because we're number 12 in the world currently. So we can provide this cleaner power, but we can also pay for using this transmission grid and infrastructure, which I think is really a really positive thing. It's not that we're completely, there's sort of mass grid defection, because I think that would be potentially a worse scenario where everyone just decides, well, I'm procuring power and I'm going completely off grid. It's like, how do we work with the existing grid we have and actually pay Eskom for the use of that service? So I really like that aspect of wheeling. And with the larger scale utility projects, I think there's a lot of, I mentioned in my response to Bernard, there's huge potential to have community ownership schemes, for example, of these projects, and to see the benefit of those projects actually translate back to the communities in which they are founded. So I think there's huge potential here, and it's really exciting. It's a really exciting space.
Thanks, Kate. Greg?
Yeah, so kind of like the future stuff that we get very excited about. What I like to see is new products coming online. So seeing things like some of the new inverters that are around, they're smarter. The batteries, of course, are much cleverer. We see, obviously, thanks to Trina and the others, we see some nice panel developments that come in and help. But what I love is, you take some guys who really have possibly got no job prospects at all, and you give them some training, some rooftop experience, some safety training, some understanding how to do things, and you see these guys develop over the years into simply like pilots of the world. They walk down into a residential installation and they're proud. They're wearing a shirt which means something, that they've done some really serious training, that they are professionals in their job, and I love seeing it. It's like a transformation. So we need a lot of those people in this industry. We need thousands and thousands of them. Sometimes people say to me, you're always helping your competitors. You always, people phone you and ask you things, and why do you help them? I say, well, God, do you know how many roofs there are in this country? There are just so many. I can't do them all. We need help. We need our industry to be professional. The more professional our industry is, the more successful we will become, and that's just the way it is. So I like the fact that it's a relatively new industry, and you can help each other. You can get things going nicely, and some companies develop into larger firms which do bigger projects, and some like to stand in whatever sector they're in. But yeah, I love it for that.
Brilliant. Thanks. Thank you so much, Greg.
Greg, I'd like to add, I commented on the other day when I mentioned our colleagues in the industry, and someone said, but are you speaking of your competition? I said, no, I'm speaking of my colleagues. And that's us. That's us. We're building an industry. If I wanted all for my own, I'm going to be very lonely eventually, I think.
Absolutely.
Another thing that I want to touch on that, Kate, also, I just want to add to that, is that one of my engineers the other day said, actually, and it was a very valid point, that utilities or municipalities for that purpose used to see their grids or networks as a liability. And they will soon learn that it's actually an asset once we start with the wheeling and trading that's now going to come soon.
Fantastic. Fantastic. Lawrence, do you want to wrap it up for us?
Yeah, look, I mean, I completely agree with what the panelists said, and it boils down again to product choice, the yields, the longevity and the quality, and also the supply chain. I mean, it's one thing to build the industry, but it's also another thing to manage the system and the processes, and to make sure that we move along as suppliers and producers. We move along at the same pace or the same speed as what is currently being built and presented or proposed. So yeah, those are the important factors for us. We definitely have products for both residential utility, or all three of them, residential, utility, and C&I. And it's always, for us, it's a game of optimizing and making sure that what we produce or what we present to the market fits within the strategy of the current situation, and complements it.
Brilliant. Thank you so much, Lawrence. I think, ladies and gentlemen, we can probably bring it to a wrap there. Just a few closing remarks. I'll do it on behalf of Niveshan. And if anyone sees him after this, please tell him I did a good job of it. Just firstly, to thank all the participants. I think at some point we were close to or over 100 participants, which is really encouraging, because the aim of these sessions is not for people who are in the space to talk to each other and sort of reaffirm each other, but to share information and to provide insights to those who might be interested in that space. And I think that's why I asked the question around, what do we need to do to make it more inclusive? This is one of the things that the industry association and our partners are doing to say this sector is still new. There's so many roofs in this country, and we need all the hands on deck to provide affordable, distributed, reliable, clean energy to as many South Africans as we can. And if there are businesses interested in it, here are the fundamentals of it. Here are your industry peers and colleagues here to lean on, to leverage from, to go into projects with. Here we are as SAPVIA, as an industry association, saying, let us walk that journey with you, whether it is through the policy, lobbying and advocacy work, whether it's through technical support, whether it's the networking opportunities that we try and facilitate, barring COVID, of course. Let us walk with you on that journey. So for all the participants that aren't SAPIA members yet, please reach out to Kim. I think I've posted her email address, but you can check our website very easily to get in touch with it. But also to note that we have 2 more sessions like this going forward. So on the 28th of October, we will be doing a session on operating and maintaining distributed generation plants. So probably a very technical session. So those in the space already wanting to understand what does it take, exploring where in the value chain you want to be, this is a session for you. And then a month later, we'll be doing solar PV and storage equals the energy future. And I think that speaks to a comment that was made by Pepsi around, we're not going to look at solar photovoltaic only. It's going to be solar PV plus storage. It's going to be solar PV plus thermal. It's going to be solar PV plus agriculture. It's going to be solar PV and water access. Really, we are a cog in this whole system. So whatever it is that we need to do to make sure the sector grows, but we achieve a just energy transition objectives, I think we're prepared to do that. So that is that. And just to thank then lastly, our panelists. Thank you so much, Greg, Kate, De Villiers, Lawrence, for your time, for your preparations, and just for being willing to share your collective, 10, 20, 30, 40 years of experience in the sector so freely and generously. Really do appreciate it. And a last thank you to the Zerni team, who's put together the entire collateral for the session and our marketing around it, and getting almost 100 people to the session on a Thursday afternoon on yet another Zoom call. Really, really do appreciate that. And yeah, I think the Secretariat of SAPIA remains open. Please reach out to us if there's any further questions you'd like answered as your panelists or guests. Do feed them in, and we will endeavor to answer all of those. Let me just check that I haven't left anything. Yeah, I think we are all good. So happy for all the panelists just to unmute and just say thank you and goodbye to all our participants. And yeah, that is it from me. So thanks, everyone.
Thanks, everyone.
Bye.
Thanks, Maloba. Thanks, everyone.
Yeah, thank you, SAPIA.
Thanks a lot, guys.